this last law of indices then, that we're looking at before the break, the last one I want to look at, there's 6 altogether, the 6th one I want you to try and just prove to yourself why it works. But I want to look at the other important one. Remember I was saying before the break that there are 2 that are really important, 4 and 5, the asterisk ones. Yes, Alan? Right, thanks for that. So, if we look at this 5th one, I want to prove why this 5th one works in a similar way to proving why the fraction works. Once you've proved it, then you just use it. So in other words, once we know the rule, we rewrite the root as x to the 2/5, or I could just as easily rewrite x to the 2/5 as the 5th root of x squared. So interchangeable, and you need to get used to be able to write them either like that or like that, and change from one to the other. Recognize that they are the same thing. So how does this one work? Well, if we look at 4 cubed divided by 4 to the power 5 and use the law of indices, the second law of indices, what would we end up with? Not 2, minus 2, because it's 3 minus 5 is minus 2, right, Daniel? Yeah. So a negative's appeared. If we look at 4 cubed and split it up into what it should be, 4 times 4 times 4, over 4 to the power 5, and then we do some cancelling, because 4 goes into 4 once, top and bottom. So I can replace 4 of the 3 4s on the top with a 1 and 3 of the 4s underneath with a 1. We end up with 1 over 4 times 4, or 1 over 4 squared. And now if we can compare these two, they are the same thing. We've just proved that. So in other words, the inverse, which is what this is, the inverse, or 1 over 4 squared, is the same as a minus power. So a negative power, pardon? Yes, that's right. Inverse means it's underneath. So if a negative power means it's an inverse. For example, how can I rewrite 3 to the minus 4? That's 1 over 3 to the 4, because minus means the inverse. How can I rewrite 1 over 2 to the power 5? 2 to the minus 5. How can I rewrite 1 over x cubed? X to the minus 3. Inverse means a negative power. It's as simple as that. What about 3 over x cubed? If you think back to the first session that we had together, and I said divide by something is the same as multiplying by 1 over it, that's the same as 3 times 1 over x cubed. So now we say to ourselves that's 3 times, how can I rewrite 1 over x cubed? X to the minus 3. So how do I rewrite 3 over x cubed? 3x to the minus 3. Yeah. Just so inverse means 1 over. If somebody asks you what's the inverse of something, it's 1 over it. And this can be written as a negative power. And that comes in very useful, particularly, as I've said already, when we want to start differentiating when we look at calculus. This becomes a very useful law of indices. So this sixth law, a to the power 0 is 1, it's just saying that anything to the power 0 is 1. Anything so any number, effectively, to the power 0 is 1. And I'll leave you to prove that that's the case in terms of the first law of indices and the second law of indices. Try and prove that a to the 0 is 1. And if you manage to do it and you want to show us how it works, that would be good. Okay? You can use similar arguments to I've been using for the other 5, or the other 3 rather, because we take as read the first 2. We can use those to prove that anything to the power 0 is 1. Those are the 6 laws of indices. What I want to do now is to focus on using those laws of indices to simplify. Let's look at this problem, and it's in the textbook, so you don't necessarily need to write this out. It's there for you to look at, but I want to look at it as a group, so don't bother to write this out. It's work problem number 10 in that chapter you're just looking at now on the laws of indices. If we look at this, though, what we do to try and simplify this is to look for bases that are the same. So, for example, we've got a occurring more than once. So I can combine that. I can say, I can rewrite this instead of a cubed b squared c. I can put the a's together. I'm using a dot for multiply. B squared times b cubed, putting the b's together, and c and c5, putting them together. So now I can combine them. Because a cubed is times by a, and remember, if there's no power there, it means a power of 1. So now I can use the first law of indices and say that's the same as a to the power 3 plus 1, which is 4, b to the power 2 plus 3, which is 5, and c to the power 1 plus 5, which is 6. So I can simplify this to give me that by adding the powers. And so we can use these laws of indices to simplify algebraic expressions. Remember the one you had in the drill? If you had some powers in there, you could simplify using these. Make sense? Let's look at another one. Fractions makes it a little bit more difficult. Same story though. Let's combine the a to the half and the a to the 6th. Put the b's together. Put the c's together. Now, what I have to do, because they multiply, is add the powers. A half plus a 6th. And b to the 2 plus a half. And c to the minus 2 plus 1. So I add the powers. The awkward one is a half plus a 6th. Can you remember what we do to add a half and a 6th? Yeah, good. A common denominator. What do 2 and 6 both go into? No, 6. 3 goes into 6, but 2 and 6 both go into 6. So, in other words, I convert the half to 6. The half is 3/6 plus 1/6. B, 2 and a half. 2 and a half. I wouldn't use 2 and a half. I'd leave it as 5 over 2. 2 and a half is 5 halves. 2 whole ones is 4 halves, plus another 1 is 5 halves. Minus 1 plus 2 is minus 1. 2 plus a half. 2 plus a half is the same as 4 halves plus a half, which is 5 halves. Thinking it is a fraction. Instead of writing it as 2 and a half, we write it as 5 over 2, because then I can write it in surd or root form using the 5th law of indices. So now 3/6 plus 1/6 is 4/6 times b to the 5 over 2 times c to the minus 1. 4 6 can be simplified though, can't it? To what? 2/3 b to the 5/2 c to the -1. But now, of course, that's fine. We can leave it like that. That's correct. And if you asked to simplify it, or you wanted to simplify it, you might well want to leave it like that. But we can now write this in root form. How can I rewrite 2/3? Right, it's a third root of, in this case, a squared. Yeah. How can I rewrite the b one? Somebody else. Right, the second root or square root of b to the 5th. And we don't bother with the 2 when we write the square root. What about c to the -1? Minus means the inverse. So 1 over c could be written like that. Which means that finally I can write this as a squared, the cube root of a squared, times the square root of b to the 5 all over c, because I can divide by c. So I could rewrite it like that. Now, the relevance of this to engineering is that you'll see things written like this, maybe, in this form. And to be able to convert from something like this and simplify it using the laws of indices to write it either like that, so I could then differentiate it, as we'll come on to, or like this, because you might see some formula written in this form and we want to be able to recognize at least that this is the same as this is the same as this. You need to be able to recognize that they're all the same thing from the laws of indices. Last one to look at, and then I'm going to give you an exercise to have a go at. Something like this. The first step in solving something like this is to remember that actually, if I've got 2 over 6, say, plus, 2 plus 3 over 6, that can be split to be 2 over 6 plus 3 over 6. I can split the fraction. And that's what I do in this case. To simplify this, the first step is to rewrite this as x squared y cubed over xy plus xy squared over xy. So I split it up. And then I try and cancel down. We can either use the law of indices here, or we can just cancel. If you look at this, x squared, remembers, means I've got 2 x's there on top. So I've got 2 x's and 3 y's, effectively. I can cancel out x on the bottom with one of the x's on the top, so leaving just x. And I cancel out that y with one of the y's, leaving squared. So this becomes just x y squared. What can I cancel out in this next one? I can take the x, off. X is cancelled, don't they, effectively? And this y cancels with one of the y's, so I can get rid of the squared, leaving just y. So this becomes xy squared plus y. Using the laws of indices looking at this, dividing means I subtract the powers. So 2 take away 1, looking at this first one, the x's, x squared divided by x, 2 take away 1 is 1, so that leaves me just 1x. Y cubed, so 3 take away 1 is 2, so that leaves me the y squared. So you can do it by just thinking of the laws of indices as well. That would be the answer. Simplified, I could factorise it to go a step further. What can I take outside the bracket that's common to both of these? Right, I can take it out. No, I can't add it to it because I can only add things that are exactly the same. So I can only add xy squareds to other xy squareds. But I can take a y outside a bracket and factorise it, which we've done some work on. And do you remember what I'm left with inside the bracket? I ask myself, what have I got to times y by to get xy squared? xy. Multiply xy by y, get xy squared. What have I got to times y by to get y? 1. So that would leave me that inside the bracket. So that's simplified. Yeah, factorise. You don't. Sometimes you do, sometimes you don't. If you're asked to, you would. But in an engineering situation, you might well want it like that, and that's fine. Or you might want to factorise it. So there's no correct answer to that. It all depends on what you're going to do next. So now try exercise 21 in your textbook, page 42.